The geological cycle consists of three phases: erosion, transportation and deposition, and earth movement. The cycle starts with the erosional phase, in which there is degradation of exposed rock by weathering processes. The weathering processes may be physical weathering or chemical weathering. Focusing on physical weathering, this process involves the erosion of rocks caused by the action of wind, water, glaciers, and disintegration caused by alternate freezing and thawing in cracks in the rock. The resulting soil particles retain the same composition as that of the parent rock. Particles of this type are described as being of bulky form. Gravel and sand fall into this group. The structural arrangement of these are described as single grain, where each particle is in direct contact with an adjoining particle, without there being any bond between them. Moving to chemical weathering, this process results in changes in the mineral form of the parent rock due to the action of water, especially if it contains acids or alkalis, oxygen and CO2. Chemical weathering results in the formation of a group of crystalline particles of colloidal size, known as clay mineral. Most clay mineral particles have a plate-like form and possess a high specific surface, that is, a high surface area to mass ratio, which significantly influences their structure by surface forces. If the products of rock weathering are still located at the place where they originated, they are called residual soil. Most residual soils are weakly bonded, have a widely varying void ratio, and contain angular rock fragments of varying sizes. Residual soils have better engineering properties. Now, looking at transportation and deposition, soil transported from their origin by wind, water, ice, or any other agency and has been deposited is called transported soil. They generally have small grain sizes and a large amount of pores. According to the transporting agency, soils are classified as alluvial deposit, deposited by river water, lacustrine deposit, deposited by still water like lakes, marine deposit, deposited by seawater, aeolian deposit, transported by wind, and glacial deposit, transported by ice. Air-transported soil have small sizes, ranging from 20 to 50 microns, and they are homogeneous, highly porous, and friable. Loess is an example of an aeolian soil, formed in arid and semi-arid regions. Alluvial soils are generally rounded and have considerable sorting. According to the transporting agency, soils are classified as 1. Water-transported soils. Swift running water carries a large quantity of soil, either in suspension or by rolling along the bed. The swift water can carry the particles of large size, such as boulders and gravels. A delta is formed when the velocity slows down to almost zero at the confluence with a receiving body of still water, such as a lake, a sea, or an ocean. All types of soils carried and deposited by river water are known as alluvial deposits. Deposits made in lakes are called lacustrine deposits. Such deposits are laminated or varved in layers. Marine deposits are formed when the flowing water carries soils to an ocean or sea. Soils deposited by wind are known as aeolian deposits. Loess is a silt deposit made by wind. These deposits have low density and high compressibility. The bearing capacity of such soils is very low. The permeability in the vertical direction is large. Glaciers are large masses of ice formed by the compaction of snow. As the glaciers grow and move, they carry with them soils varying in size from fine grain to huge boulders. Soils get mixed with the ice and are transported far away from their original position. Drift is a general term used for the deposits made by glaciers directly or indirectly. Deposits directly made by melting of glaciers are called till. Deposits of glacial till are generally well graded and can be compacted to a high dry density. These have generally high shearing strength. Colluvial soils, such as talus, have been deposited by the gravity. Talus consists of irregular, coarse particles. Sometimes, two or more agents of transportation act jointly and transport the soil. For example, a soil particle may fall under gravity and may be carried by wind to a far-off place. It might be picked up again by flowing water and deposited. A glacier may carry it still further.